Welcome. Tonight, there is nothing you need to understand, nothing you need to remember, only distance. If you've ever looked up at the night sky and noticed a faint, cloudy smudge between the stars, you've already seen it, not through a telescope, not through a photograph, but with your own eyes. That faint glow is not a nebula, not a trick of light, and not part of our own galaxy. It is another galaxy entirely, drifting quietly through space. Its name is Andromeda. From here, it appears small, easy to ignore, something that fits comfortably into a single glance. But that impression is deeply misleading, because the light reaching your eyes tonight began its journey millions of years ago, traveling across a distance so vast that the human mind cannot truly hold it. Andromeda is not far away in the way cities are far away. It is far away in time, far away in scale, far away in a way that slowly dissolves familiar meaning. As you settle in and let your attention soften, we're going to explore the true scale of Andromeda, not by rushing through numbers or forcing understanding, but by gently expanding perspective, letting distance stretch, letting size unfold, letting the galaxy become less like an object and more like an environment. There is nowhere to arrive, only space to drift through. And we'll begin with what Andromeda seems to be, before discovering what it truly is: the smudge in the sky. On a clear night, far from city lights, the sky opens in a way that feels ancient. Stars appear not as isolated points, but as a quiet field stretching in every direction. Most of what we see looks familiar. Constellations form shapes we've learned to recognize. Patterns repeat themselves night after night, steady and dependable. But among these familiar stars, there is something else, something softer, something less defined. It does not sparkle. It does not draw attention. It does not announce itself. At first glance, it looks like a faint blur, a thin cloud of light, barely brighter than the darkness around it. Many people mistake it for a smudge on the eye, or a patch of haze in the atmosphere. Some never notice it at all, yet this subtle glow has been seen by human eyes for thousands of years, long before telescopes, long before astronomy had a language for galaxies. This faint presence is Andromeda. From Earth, Andromeda does not look impressive. It occupies only a small portion of the sky, easily overlooked among brighter stars and familiar patterns. It does not dominate the night. It does not overwhelm the senses. In fact, it feels almost fragile, as if it could vanish at any moment if the sky were just a little brighter or the air slightly less clear. Because it is visible without instruments, the mind treats it casually. Something seen with the naked eye must be close. Something that small must be manageable. Something that quiet must be simple. This assumption feels natural. On Earth, visibility and distance are closely linked. Mountains appear large because they are near. Cities glow brightly because they are close. Things that are far away grow faint, small, and indistinct. Our brains have learned this relationship through a lifetime of experience. It is reliable. It works well in the world we evolved to navigate. But the universe does not follow this rule. Andromeda appears faint, not because it is small, and not because it is weak, but because it is unimaginably distant. The light reaching your eyes has traveled across space for more than 2 million years, crossing distances so vast that even the fastest objects humans have ever built would not make meaningful progress toward it. The glow you see tonight began its journey long before human history had names, before agriculture, before written language, before memory itself. Yet despite this distance, Andromeda remains visible. That fact alone should feel strange. To be seen across millions of light years means emitting an extraordinary amount of light. It means containing not just a few stars, but hundreds of billions of them, shining together. their combined glow surviving a journey that erases nearly everything else. What appears faint is not weak. It is resilient. Still, the eye does not perceive it this way. The glow is soft. The edges are indistinct. There is no sharp outline to define where it begins or ends. It feels incomplete, as though we are only seeing part of it. And that feeling is accurate. What the eye detects is not Andromeda in its entirety, but only its brightest region. The dense core, where stars are packed more closely together, producing enough combined light to stand out against the darkness of space. Everything beyond that, the outer stars, the extended structure, the vast halo, remains hidden from unaided human vision. In reality, Andromeda stretches far beyond what we can see. Its visible shape is only the central glow of a much larger system, one that fades gradually rather than ending abruptly. The galaxy does not have edges in the way objects on Earth do. It thins out. It dissolves slowly into space, becoming fainter and more diffuse until it blends seamlessly into the cosmic background. This gradual fading creates an illusion. It makes the galaxy feel smaller than it is. It allows the mind to compress something enormous into a manageable shape. And because the human brain prefers simplicity over uncertainty, it accepts this compression without question. Andromeda becomes just another feature of the sky. For centuries, this is how it was understood. Ancient observers described it as a cloud or a nebula, a curious patch of light with no clear explanation. Even when telescopes were first turned toward it, Andromeda remained mysterious. Early astronomers could see that it contained stars, but they did not yet know what those stars meant. The idea that Andromeda was an entirely separate galaxy, existing far beyond the Milky Way, did not arrive easily. When that realization finally came, it quietly redefined the universe. Andromeda was not a nearby object within our own galaxy. It was another galaxy entirely, comparable in size to the Milky Way, existing far beyond it. The night sky was no longer just a collection of stars surrounding us. It was a window into a universe filled with other island systems, each containing billions of suns, drifting silently through space. Yet even with this knowledge, Andromeda still looks the same to the naked eye. It remains a faint blur, a quiet presence, something easy to underestimate. This disconnect between appearance and reality is the beginning of the problem. The universe often hides its true scale behind subtlety. It does not overwhelm us with obvious signs of size. Instead, it presents immense structures in gentle forms, requiring patience and perspective to understand. Andromeda's small appearance is not a failure of observation. It is a consequence of distance. The farther something is, the more its light spreads out before reaching us. Even a galaxy larger than our own can be reduced to a thin glow when viewed across millions of light years. This reduction strips away depth. It flattens structure. It removes context. When you look at Andromeda, you are not seeing layers of stars at different distances. You are seeing all of them projected onto a single surface of sky. The brain, lacking depth cues, treats them as though they exist on the same plane as nearby stars, even though they are separated by unimaginable distances. This flattening effect makes the universe feel smaller than it is. Stars that are light years away and galaxies that are millions of light years away appear side by side, sharing the same backdrop. Without conscious effort, the mind assumes they belong to the same scale. Andromeda feels like just another distant star, not a vast system of stars in its own right. The night sky becomes deceptive, calm, orderly. But beneath that calm appearance lies a reality far more expansive. Andromeda is not hovering near the Milky Way. It is not tucked neatly into the sky. It is a structure so large that it contains room for entire histories to unfold within it. Civilizations could rise and fall on planets orbiting its stars without ever perceiving the galaxy as a whole. Time moves slowly at this scale. Motion unfolds across millions of years. Change becomes almost imperceptible. From Earth, none of this is obvious. We see a smudge. We think we understand it, and then we move on. This is not because we lack intelligence or curiosity. It is because our senses were never designed to interpret structures of this magnitude. The human brain evolved to track movement, detect threats, recognize patterns at human distances. It is excellent at navigating forests and plains. It is not built to intuit galactic scale. And so, it simplifies. Andromeda becomes small enough to fit into the sky we know. Its distance becomes abstract. Its size becomes theoretical. Yet the galaxy itself does not change. It continues to rotate slowly, stars orbiting its center over hundreds of millions of years. Gas clouds collapse and form new stars. Old stars burn out and fade. Dark matter holds the structure together, extending far beyond the light we can see. All of this happens whether or not anyone is watching. The faint glow remains steady, arriving night after night, unchanged by attention. This quiet persistence is part of what makes Andromeda so powerful as an object of contemplation. It does not demand understanding. It does not challenge us directly. It simply exists, carrying its vastness lightly, offering only a hint of what lies beyond perception. As you settle into this idea, there is no need to force comprehension. There is nothing to calculate, nothing to memorize. The goal is not to grasp the galaxy all at once, but to notice how easily it slips past awareness. A structure larger than our own galaxy can appear as a soft blur in the sky. A system containing hundreds of billions of stars can feel insignificant at a glance. A presence millions of light years away can seem quietly nearby. This is the paradox that opens our journey. We think we see Andromeda, but what we see is only a suggestion. What we're actually looking at. When you look at Andromeda, it feels complete. The glow appears contained, balanced, and finished, as though the galaxy has revealed itself in full. There is a center, softly brighter than the rest, and a gradual fading outward that suggests a natural boundary. The mind accepts this image without resistance. It feels whole enough to move on from. But this sense of completeness is an illusion created by limitation rather than truth. What you are seeing is not the galaxy itself, but a narrow slice of what is visible to human perception. The light that reaches your eyes comes only from regions dense enough and bright enough to survive an extraordinary journey through space. Everything else remains present, but unseen. The galaxy does not disappear where your vision ends. It simply continues beyond it. Light is selective. It favors concentration. It reveals where stars are crowded together and hides where they are sparse. In Andromeda, the stars near the center are packed more tightly, their combined glow strong enough to travel across millions of light years. Farther out, stars grow more distant from one another. Their light spreads thinly across space, becoming too faint to stand out against the cosmic background. This gradual thinning does not mean emptiness. It means scale. Imagine standing at the edge of a city at night. From a distance, the center glows brightly, a concentrated mass of light. As you move outward, the lights grow fewer, streets become darker. Eventually, the glow fades into scattered points, and then into darkness. The city has not ended abruptly. It has simply spread out. Andromeda behaves in the same way, but on a scale so vast that the analogy almost fails. Its bright core is only the most concentrated region of a structure that extends far beyond what the eye can register. The galaxy's true form is not a disk with a clear edge, but a layered system that grows quieter and more diffuse the farther you move from its center. From Earth, we mistake this fading for an ending. The instruments we use shape what we believe. The naked eye sees only what is bright enough. Early telescopes revealed more, but still only a fraction. Each improvement in technology has expanded Andromeda's apparent size, pushing its boundaries farther into darkness. With every new observation, the galaxy grows larger, not because it is changing, but because we are seeing more of what was always there. This means that every image you have ever seen of Andromeda is incomplete. Photographs capture light. They do not capture gravity. They do not show dark matter. They do not reveal the full extent of the galaxy's influence. They present a beautiful, detailed portrait of the brightest regions, but leave out the majority of the structure that defines Andromeda's true scale. Even the most detailed images, taken with powerful telescopes, show only a portion of the galaxy's stars. Surrounding that visible structure is a vast halo of stars, so faint and spread out that they barely register at all. Beyond even that lies an enormous region, dominated by dark matter, completely invisible, yet essential to the galaxy's existence. This invisible structure outweighs the visible one. The galaxy you think you see is not the galaxy that exists. From Earth, Andromeda fits comfortably into a patch of sky. From within, it would feel endless. The difference between these two perspectives is not just a matter of distance, it is a matter of perception. When something is far away, the mind compresses it. Depth collapses. Size becomes suggestion. A mountain seen from a great distance looks small enough to climb in an afternoon, even though it may take days. The same effect applies to galaxies, only far more dramatically. Andromeda's immense size is flattened into a faint oval because the mind has no alternative framework. There is no familiar reference for a structure that spans hundreds of thousands of light years. Without a way to compare it meaningfully, the brain reduces it to what it can manage. This reduction happens quietly and automatically. You do not feel confused when you look at Andromeda. You feel calm. You feel oriented. You feel as though you understand what you are seeing. This is what makes the illusion so effective. The night sky feels orderly because it hides its depth. Stars appear evenly spaced. Galaxies look small. Vast differences in distance collapse into a single visual plane. The universe presents itself as something you can look at all at once. But you cannot. What appears as a flat sky is actually a layered volume of space stretching outward in every direction. Some of the light reaching your eyes began its journey a few years ago. Some began millions of years ago. Some began billions of years ago. All of it arrives together, creating the illusion of simultaneity. Andromeda's light belongs to the deeper layers of that volume. When you look at it, you are not just seeing across space, you are seeing across time. The galaxy you perceive no longer exists in the form you see. Stars have moved, new stars have formed, old ones have died. The image is accurate, but it is outdated. This does not make it false. It makes it historical. Andromeda is a record as much as it is an object. Its light is a message sent long ago, arriving patiently, unchanged by the events that followed its departure. The galaxy you see is real, but it is not current. This temporal distance adds another layer to the illusion of smallness. Things from the past feel distant and disconnected. They feel contained by memory rather than active in the present. Andromeda, viewed through ancient light, takes on a similar quality. It feels removed, quiet, and static. In reality, it is none of these. The galaxy is dynamic. Stars orbit its center in slow, graceful arcs. Gas clouds drift and collide, giving birth to new stars. Dark matter holds the structure together, guiding motion on scales far beyond visibility. All of this happens continuously, even though we see only a frozen moment from the past. This mismatch between appearance and activity further separates perception from reality. From Earth, Andromeda feels like a picture. From within, it would feel like a place. The galaxy's true size cannot be understood by looking at it alone. It must be inferred. It must be felt indirectly, through the behavior of stars, through the reach of gravity, through the subtle ways it shapes the space around it. This indirectness makes Andromeda easy to underestimate. We trust our eyes. We trust what we can see. And when something looks small, we assume it is. But in space, the largest things often appear the quietest. The universe does not advertise its scale. It does not provide clear markers or boundaries. It allows immense structures to exist without spectacle, revealing only what must be revealed for light to travel. Andromeda's faint glow is not an invitation to understand. It is a hint that understanding will require patience. As you rest with this idea, it becomes easier to release the need for clarity. The galaxy does not need to be pinned down or defined. It does not need to be reduced to an image or a number. It can be allowed to exist as something larger than perception, something that continues beyond the limits of sight. This release is important. Once the assumption of completeness is let go, scale begins to expand naturally. The mind becomes more receptive to the idea that what is seen is only a fraction of what exists. Curiosity replaces certainty. Space opens rather than closes. Andromeda becomes less like an object and more like an opening, a reminder that the universe is layered, deep, and resistant to simplification. We have not yet begun to measure it. We have not yet compared it. We have not yet placed it in context. For now, it is enough to recognize that the galaxy we think we see is only a suggestion of something far larger, a quiet surface hinting at a depth that cannot be taken in all at once. And with that understanding gently in place, the journey can continue, not toward answers, but toward perspective, toward the slow expansion of scale that will reshape how distance, size, and presence are felt. The smudge in the sky has not changed. Only our relationship to it has begun to shift. Human scale is small by design. The human mind did not evolve to understand galaxies. It evolved to survive on a small world, under a nearby sun, within distances that could be crossed on foot or, at most, over the course of a lifetime. Our senses are tuned to movement we can react to, sounds we can localize, and spaces we can navigate without losing orientation. This tuning works remarkably well on Earth. It keeps us alive. It keeps the world feeling stable and coherent. But when the same perceptual system is applied to the universe, it begins to fail quietly. Scale, at cosmic distances, does not behave the way it does in everyday life. The brain expects size to announce itself. Large things should look large. Distant things should fade smoothly into insignificance. Objects should become smaller as they move away, until they disappear entirely. These expectations are built into perception itself, shaped by millions of years of experience in a gravity-bound, atmosphere-filled environment. The universe does not honor these expectations. When you look at the night sky, your brain interprets it as a surface rather than a volume. Stars appear to be embedded in a vast dome, equally distant, evenly spaced. The sky feels flat, even though it is anything but. This flattening is not a mistake. It is a survival feature. The brain simplifies depth when reliable cues are missing. On Earth, depth is easy to judge. Objects overlap, shadows shift, perspective changes as you move. In space, these cues disappear. Light arrives from every direction without context. Distance becomes ambiguous. The brain resolves this ambiguity by compressing space into a single visual plane. This is why the moon looks roughly the same size in the sky as the sun, despite being vastly smaller. This is why distant mountains appear close enough to touch. And this is why Andromeda, a galaxy larger than the Milky Way, can appear as a faint blur among nearby stars. Your brain is not lying to you. It is protecting you from overload. If perception reflected true cosmic scale, the universe would feel disorienting and uninhabitable. The sky would feel bottomless. Distance would feel infinite. Motion would feel meaningless. The mind would struggle to anchor itself to anything familiar. Instead, perception simplifies. Stars become points. Galaxies become smudges. Vastness becomes background. This simplification allows the mind to remain calm. It prevents the universe from feeling overwhelming, but it also hides the true nature of what we are observing. When you see Andromeda, your brain does not register it as a system of hundreds of billions of stars spread across hundreds of thousands of light years. It registers it as a faint object occupying a small area of the visual field. Size is measured not by reality, but by appearance. This is why cosmic scale feels unreal even when it is explained clearly. The numbers may be understood intellectually, but they do not integrate into perception. The galaxy remains small in the mind because it remains small in the eye. The brain has no intuitive category for something that is both distant and immense. On Earth, distance usually reduces importance. Faraway things matter less because they affect us less. In space, distance does not reduce significance. It simply delays information. Andromeda is distant, but it is also massive. Its gravity shapes space far beyond its visible glow. Its future is intertwined with that of the Milky Way. Yet because it is far away, the mind places it in the category of background rather than presence. This mismatch creates a subtle tension. We know, intellectually, that Andromeda is enormous, but we feel, perceptually, that it is small. The brain resolves this tension by favoring perception over abstraction. What we see feels more real than what we calculate. This is not a flaw. It is how cognition maintains stability. The universe becomes navigable not because it is small, but because it is simplified. As you rest with this idea, there is no need to correct perception or force understanding. The goal is not to override the brain's natural responses, but to notice them gently. To recognize that scale is not failing to be understood, it is being filtered. And once that filter is noticed, it becomes possible to loosen it slightly. Not to grasp the universe all at once, but to allow space to feel deeper than it appears. To allow distance to feel layered rather than flat. To allow Andromeda to exist not as a small object in the sky, but as something whose presence extends far beyond what the eye reports. This shift does not require effort. It happens naturally when urgency is released. When there is no need to solve, measure, or conclude, the mind becomes more open to vastness without resistance. The universe does not need to be reduced to feel safe, and scale does not need to be mastered to be felt. Light years are time, not distance. When we hear the word distance, we usually imagine space, a gap between 2 points, something that can be crossed, measured, or gradually closed. On Earth, distance is physical and immediate. You can walk it, drive it, or watch it pass beneath you as you move. Time and distance are separate experiences, even though they are connected. In space, this separation dissolves. The vast distances between stars and galaxies are not meaningfully described by kilometers or miles. These units grow too large, too abstract, to carry emotional weight. Instead, astronomers use light years, a measure that quietly blends distance and time into a single idea. A light year is not a place, it is a duration. It describes how far light can travel in 1 year, moving at the fastest speed the universe allows. This changes everything about how distance should be understood. When we say Andromeda is more than 2 million light-years away, we are not simply describing how far it is. We are describing how long its light has been traveling to reach us. The glow you see tonight began its journey long before the first human stories were told, before memory became history, before language shaped thought. That light has been moving uninterrupted ever since, crossing the quiet expanses between galaxies, arriving only now. In this sense, looking at Andromeda is not looking outward so much as looking backward. Every photon reaching your eyes carries a moment from the past. Not a recent past, but a deep one. The galaxy you see no longer exists in the form you perceive. Stars have shifted. Orbits have evolved. New stars have formed where none existed before. Others have faded into remnants. The image is accurate, but it is delayed. This delay is not noticeable in daily life. On Earth, light travels so quickly that the time it takes to cross familiar distances is negligible. A room, a city, even the distance between the Earth and the Moon all feel immediate. The universe, however, operates on scales where light itself becomes slow. Andromeda is so distant that its present state is unknowable in real time. There is no way to see it as it is now. We can only see what it was. The galaxy exists in two forms simultaneously: as a living, evolving structure in the present, and as a historical image, arriving from the past. The mind struggles with this duality. We are accustomed to seeing things as they are. Our senses are tuned to immediacy. When we look at an object, we assume it exists in the same moment we do. Space challenges this assumption, gently but persistently. The farther away something is, the farther back in time we see it. At small distances, this effect is invisible. At cosmic distances, it defines reality. Andromeda's distance is not just a spatial separation, it is a temporal one. The galaxy feels static not because it is unchanging, but because change unfolds too slowly to be seen across millions of years. Motion becomes invisible when observed through ancient light. This further contributes to the illusion of smallness. Things that feel old and static tend to feel contained. They feel finished. Andromeda's faint glow carries the quiet stillness of deep time, reinforcing the impression that it is distant, inactive, and complete. In truth, the galaxy is dynamic. Stars orbit its center over hundreds of millions of years. Gas clouds drift, collide, and collapse, forming new stars. Dark matter shapes motion on scales far beyond visibility. All of this is happening continuously, even though we see only a frozen moment from the distant past. The mind has no intuitive way to reconcile this. We are not built to experience time at this scale. 2 million years feels infinite, yet in cosmic terms, it is a brief interval. The universe has existed for billions of years. Galaxies have formed, evolved, and interacted across timescales that dwarf human history. This mismatch between human time and cosmic time deepens the gap between perception and reality. When something takes longer than a lifetime to change, it feels eternal. When something existed long before us, it feels detached. Andromeda, seen through ancient light, carries both of these qualities. It feels removed from the present, even though it is actively shaping the future. This is why cosmic distances feel unreal. They cannot be integrated into lived experience. They exist outside memory, outside anticipation, outside the rhythms that define everyday life. The mind treats them as abstractions because there is no alternative. Yet abstraction does not mean insignificance. The future of Andromeda is intertwined with our own. Its motion through space, guided by gravity, is slowly bringing it closer to the Milky Way. This approach will take billions of years to unfold, but it is already underway. The galaxy you see as a faint blur is moving, changing, and interacting, even though none of this is visible to the eye. Understanding distance as time softens the need for clarity. There is no need to imagine crossing the space between galaxies. There is no need to picture a journey. The distance is not meant to be traveled. It is meant to be observed as a span of history. When we release the idea that distance must be conquered, it becomes easier to accept its scale. The universe does not ask us to go there. It asks us to look quietly and recognize that what we see is layered across time. Andromeda is not far away in the way cities are far away. It is far away in the way epochs are far away, in the way beginnings are far away. This reframing changes how scale is felt. The galaxy no longer needs to be visualized all at once. It can be allowed to exist across time rather than space. Its size becomes something that unfolds slowly rather than something to be grasped immediately. As the mind rests in this idea, the pressure to understand fades. There is nothing to calculate, nothing to reach. Only the recognition that the universe is larger than immediacy allows, and deeper than perception suggests. Distance becomes calm rather than daunting. Time becomes expansive rather than threatening. Andromeda remains where it has always been, its light continuing, its long journey toward Earth, arriving patiently, moment by moment. Whether or not we fully understand its scale does not change that journey. Why galaxies have no borders? On Earth, size feels certain. Objects begin somewhere and end somewhere else. A room has walls. A forest has an edge where trees thin and fields begin. Even the largest natural features eventually give way to something different. These boundaries help the mind organize space. They provide clarity. They make the world feel contained. In space, this sense of containment quietly dissolves. Galaxies do not have borders in the way we expect. There is no outer wall, no final line where a galaxy simply stops. Instead, galaxies fade. They thin. They dissolve gradually into the surrounding universe. Their structure becomes quieter the farther one moves from the center, until it blends so seamlessly with intergalactic space that the transition is almost impossible to mark. This lack of a clear boundary is one of the reasons galactic size feels so difficult to understand. We instinctively look for edges. We want to know where something ends so we can say how large it is. But a galaxy does not cooperate with this instinct. It resists being framed. Andromeda, like all large galaxies, is built in layers. At its heart lies a dense central region where stars are packed more closely together. This region glows brightly and dominates images taken from Earth. Moving outward from the center, stars become more spread out. The light fades slowly. Structure remains, but it becomes subtle. At no point does the galaxy suddenly end. From far away, this gradual fading gives the impression of a disk with a defined shape, but that shape exists only because light becomes too faint to detect beyond it. The galaxy itself continues, its stars stretching farther into space, their presence revealed only by careful observation. This is why measurements of galactic size change over time. As instruments become more sensitive, astronomers detect stars farther and farther from the center, expanding the known dimensions of the galaxy. What once seemed complete is revealed to be only a portion of a much larger structure. Andromeda's size has grown not because the galaxy is expanding rapidly, but because our ability to see it has improved. The idea of size in space, then, is not about physical limits. It is about influence. A galaxy extends as far as its gravity can hold stars and gas together. Where gravity weakens and stars drift freely, the galaxy's presence begins to fade. Gravity does not stop abruptly either. Like light, it diminishes gradually. This creates a region where it becomes unclear whether a star belongs to one galaxy or to the space between galaxies. Membership becomes a matter of probability rather than certainty. This uncertainty challenges the way we think about size. On Earth, size is definitive. In space, it is contextual. It depends on what you are measuring and how sensitive your tools are. The same galaxy can have different sizes depending on whether you are tracing light, stars, gas, or gravity. This flexibility is not a flaw in measurement. It is a reflection of how the universe is structured. Space does not divide itself into neat compartments. It flows. It overlaps. Structures exist within one another, layered rather than separated. Andromeda is not an isolated island floating in emptiness. It is embedded in a web of matter and gravity that connects it to its surroundings. Its stars extend outward. Its dark matter halo reaches even farther, and beyond that lies the shared gravitational landscape of the local group. In this context, asking where Andromeda ends becomes less meaningful. The galaxy does not end so much as it transitions. It gives way to something quieter, more diffuse, but still connected. This gradual transition is difficult to visualize because it lacks contrast. The human mind prefers clear differences. It notices boundaries because boundaries signal change. When change is slow and continuous, it often goes unnoticed. This is why Andromeda feels smaller than it is. Its scale unfolds gradually, without dramatic markers. There is no single feature that announces the galaxy's full extent. Its vastness is distributed across space rather than concentrated in a visible edge. Imagine walking away from a campfire at night. At first, the fire is bright and warm. As you move farther away, the light dims, the warmth fades, and eventually, both disappear. There is no point at which the fire suddenly stops existing. There is only a gradual loss of sensation. A galaxy behaves in much the same way, except that the distances involved are measured in tens or hundreds of thousands of light years. The transition from bright core to faint outskirts unfolds so slowly that it cannot be perceived directly from Earth. From within the galaxy, the experience would be different. There would be no sense of crossing a boundary. One region would flow into another, stars growing more sparse, the sky gradually darkening. The galaxy would feel less like an object and more like a vast environment. This environmental scale is difficult to communicate because it does not fit neatly into diagrams or numbers. It must be inferred, felt through implication, rather than seen directly. Andromeda's true size reveals itself not through appearance, but through patience. When astronomers speak of Andromeda's diameter, they are choosing a definition for practical reasons. They draw an approximate line where the density of stars drops below a certain threshold, or where gravitational influence weakens beyond detection. These lines are useful, but they are not absolute. The galaxy does not recognize these lines. Its stars continue to orbit. Its gravity continues to reach outward. Its presence continues to shape space, even where it becomes difficult to measure. In this sense, Andromeda is larger than any single number assigned to it. Understanding this changes the way scale feels. Size becomes something fluid rather than fixed. It is not a matter of containment, but of reach. A galaxy is as large as its influence, and that influence extends far beyond what the eye can see. This is why Andromeda's true scale cannot be captured in a single image or statistic. It is not defined by its brightest stars, but by the quiet outskirts where structure fades into possibility. As this idea settles, the galaxy begins to feel less like a distant object and more like a gradual presence, something that does not end so much as it continues, thinning into the vastness of space. Measuring without rulers. Because galaxies have no clear borders, Measuring them requires a different way of thinking. On Earth, measurement is direct. You place markers, you draw lines, you compare one edge to another. In space, none of this is possible. There is nothing solid to touch, nothing fixed to anchor a boundary. Instead, astronomers measure indirectly, observing motion, light, and influence, and then allowing patterns to emerge slowly over time. One of the most revealing tools is motion. Stars within a galaxy do not sit still. They orbit the galactic center, each following a slow path shaped by gravity. By observing how fast these stars move at different distances from the center, astronomers can infer how much mass lies within those orbits. Where stars continue to move as though held tightly, mass must be present, even if it cannot be seen. This approach revealed something unexpected. In Andromeda, stars far from the visible core move faster than the light alone would predict. If only the visible stars were present, the galaxy should not be able to hold itself together. The outer stars should drift away. Instead, they remain bound, circling patiently in the dark. This motion tells a quiet story. It reveals the presence of vast amounts of unseen mass extending far beyond the bright regions of the galaxy. And with that realization, Andromeda's size expands dramatically. The galaxy is no longer defined by what glows, but by what holds. Light shows only a fraction of the structure. Motion reveals much more. Astronomers also look for faint stars far from the galaxy's center, stars that belong to Andromeda but lie well beyond its bright disk. These stars are difficult to detect. They do not stand out. They do not form obvious patterns. They drift quietly in the outskirts, tracing the galaxy's extended reach. Each time such stars are found, the known size of Andromeda increases. The galaxy stretches farther into space, its halo growing larger and more complex. What once seemed like an outer limit becomes merely another layer. There is no moment where discovery feels complete. Measurement in space is always provisional. It reflects what can be detected at a given time, with a given level of sensitivity. As instruments improve, boundaries move outward. The galaxy grows not because it is changing rapidly, but because our view of it is deepening. This gradual expansion of understanding mirrors the galaxy's own nature. Andromeda is not a compact object waiting to be defined. It is a diffuse system whose influence fades slowly rather than ending suddenly. Measuring it is less about precision and more about patience. Even defining the center of a galaxy involves approximation. While Andromeda has a dense central region, that center is not a fixed point in space. It is a dynamic area shaped by the motion of stars, gas, and dark matter. Over immense timescales, even the core evolves. This fluidity challenges the idea of size as something stable and permanent. In space, size is not fixed. It is a relationship between matter, motion, and gravity. A galaxy is large because its influence is wide, not because it occupies a sharply defined volume. From Earth, this can feel unsettling. We are accustomed to certainty. We like numbers that settle questions. But Andromeda resists final answers. Each attempt to define its scale opens new questions about what lies beyond the current limits of detection. This resistance is not a flaw. It is an invitation to think differently. Instead of asking how big Andromeda is, it becomes more useful to ask how far its presence reaches. Where does its gravity still shape motion? Where do stars still behave as part of a shared system? Where does order give way to independence? These questions do not have precise answers, only ranges and probabilities. The galaxy's size becomes a zone rather than a line, a region of influence rather than an enclosed shape. This way of thinking aligns more closely with how the universe actually works. Space is not divided cleanly. Structures overlap, forces intermingle. Andromeda exists within a broader cosmic environment, its influence blending gradually into that of other galaxies. When we accept this, the need for exact measurement fades. Scale becomes something to sense rather than define. The galaxy feels larger not because we can assign it a number, but because we understand that its reach exceeds what is visible. Andromeda's true size is not contained within images or diagrams. It lives in the quiet motions of stars, in the unseen pull of gravity, and in the slow unfolding of structure across immense distances. As this idea settles, measurement becomes less about control and more about observation. The galaxy does not need to be framed to be appreciated. It does not need to be bounded to be understood. It simply exists, vast and patient, extending outward beyond certainty, beyond the visible disk. From Earth, Andromeda appears to have a shape that feels complete. A long, soft oval of light stretches gently across the sky, brighter at the center and fading at the edges. This shape feels familiar and reassuring, as though the galaxy has revealed itself fully, offering a clear sense of its size and form. The mind accepts this outline without hesitation. It feels finished. But this visible disk is only the brightest layer of something far larger. What we see is the region where stars are packed closely enough for their combined light to stand out across immense distances. Beyond this bright disk, Andromeda does not end. It continues outward, growing quieter and more diffuse, its stars spreading farther apart, their light blending into darkness. The galaxy becomes harder to see, not because it is no longer there, but because it no longer announces itself. This fading creates a powerful illusion. It suggests a boundary where none truly exists. The eye interprets the limit of visibility as the limit of structure. The mind completes the picture, assuming that what cannot be seen does not matter. In reality, Andromeda's visible disk is surrounded by a vast population of stars that orbit far beyond the bright core. These stars are part of the galaxy just as surely as those at the center. They move under the same gravitational influence. They share the same slow rotation. They belong, even though their light is faint. Astronomers began to notice this hidden population as observation techniques improved. Long exposures revealed faint arcs and streams of stars far from the main disk, subtle patterns that could not be explained as background noise. These stars were moving together, behaving as part of a coherent system. Andromeda, it became clear, extended much farther than previously thought. This outer region is known as the stellar halo. It is not dense, it does not glow brightly. Instead, it forms a vast, nearly spherical cloud of stars surrounding the galaxy. From Earth, it is almost invisible. From within, it would feel immense. The halo does not have a sharp edge. Like the galaxy itself, it fades gradually. Stars grow fewer and farther between as one moves outward. The transition from galaxy to intergalactic space happens slowly, without a clear dividing line. This softness makes the true width of Andromeda difficult to define. In some regions, stars in the halo are remnants of smaller galaxies that once drifted too close. Over time, Andromeda's gravity pulled them apart, stretching their stars into long, faint streams that now wrap around the galaxy. These streams are records of ancient interactions, preserved not in sound or memory, but in motion. Each stream marks a place where Andromeda grew larger, not by expanding outward suddenly, but by quietly incorporating what passed nearby. The galaxy's width, then, is not only a measure of distance, but a history of interaction and accumulation. From far away, this history is invisible. The bright disk hides it. The eye sees a clean shape and assumes simplicity. But beneath that simplicity lies a layered structure shaped by billions of years of slow change. The farther astronomers looked, the wider Andromeda became. Stars once thought to be isolated were revealed to belong to its outer reaches. Regions once considered empty were shown to be part of the galaxy's extended domain. The true width of Andromeda expanded outward, dissolving earlier assumptions. This expansion did not come with drama. There was no single discovery that suddenly doubled the galaxy's size. Instead, understanding grew incrementally. Each faint detection nudged the boundary farther away. Each improvement in sensitivity revealed another quiet layer. This gradual unfolding mirrors the way Andromeda itself exists. Nothing happens quickly. Change arrives slowly, accumulating over vast spans of time. The galaxy does not announce its size. It reveals it only to those willing to look patiently. From within the halo, the galaxy would not feel like a disk at all. The sky would be filled with stars in every direction, though more sparsely than near the center. There would be no clear sense of inside or outside, only a gradual shift in density. The concept of width would lose its meaning. This perspective helps explain why Andromeda feels smaller than it is. Width, as we experience it on Earth, relies on boundaries and contrast. In space, where structures fade rather than stop, width becomes subtle and difficult to perceive. Andromeda's true width is not defined by its brightest stars, but by the quiet outskirts where gravity still holds sway. It extends far beyond what images suggest, reaching into regions where light barely whispers its presence. As this idea settles, the galaxy begins to feel less like a distant object and more like a vast, layered presence. Its width is not something to be measured precisely, but something to be slowly acknowledged. Larger than the Milky Way. For a long time, the Milky Way was assumed to be the standard by which other galaxies were measured. This made sense. We live inside it. Its stars fill our sky. Its structure surrounds us so completely that it feels immense beyond comparison. Andromeda, seen from the outside, appeared similar in size, perhaps slightly smaller, perhaps roughly equal. From a distance, the two galaxies seemed like peers. But distance can be misleading. As astronomers learned to look beyond visible light and into the faint outskirts of galaxies, this assumption began to soften. Measurements of Andromeda's outer stars revealed something unexpected. Its stellar halo extended farther than anticipated, stretching outward in broad, quiet arcs. The galaxy was not simply comparable to the Milky Way. It was wider. This realization did not arrive suddenly. It emerged slowly, as faint stars were detected farther and farther from Andromeda's center. Each new observation pushed the galaxy's known boundaries outward. What once felt complete became provisional. The more carefully Andromeda was studied, the more it expanded. In terms of visible light alone, the Milky Way and Andromeda appear similar. Both have bright central regions and sprawling disks of stars. But when width is measured by the reach of stars and gravity, Andromeda begins to stand apart. Its outer regions stretch farther into space, forming a halo that envelops a larger volume. This difference is subtle when viewed from Earth. From our position inside the Milky Way, it is difficult to judge our own galaxy's full extent. We see its stars projected across the sky, layered and overlapping, without a clear sense of depth. Andromeda, viewed from the outside, offers a cleaner comparison. Its structure can be traced more easily, its outer limits inferred through motion and distribution. Through these comparisons, Andromeda gradually emerged as the dominant system in our local region of space. It contains more stars than the Milky Way. Its gravitational influence reaches farther. Its halo is broader and more massive. In quiet ways, it outweighs us. This does not diminish the Milky Way. Our galaxy remains vast beyond human scale, but it reframes our place in the local universe. We are not at the center of the largest structure nearby. we are neighbors to something even more expansive. The realization carries a subtle emotional shift. There is comfort in believing one's home is the largest thing around. There is also humility in discovering it is not. Andromeda's greater width reminds us that perspective matters. What feels central from within can appear different from without. The outer regions of Andromeda do more than extend its size. They also bring it closer to us than it appears. While the bright cores of the two galaxies remain separated by millions of light years, their halos reach outward into shared space. The faint outskirts of Andromeda and the Milky Way are not isolated. They overlap gently, mingling in a region shaped by both galaxies' gravity. This overlap is not dramatic. There are no visible signs of collision, no sudden changes in the sky. Instead, it is a quiet interaction, unfolding over immense timescales. The galaxies are already connected, not by light, but by influence. In this sense, Andromeda is not just larger than the Milky Way, it is closer than it looks. Its presence is already shaping the space around us, even though its visible form feels distant and contained. Understanding this reshapes the idea of width once again. Andromeda's true width is not confined to its own stars. It includes the region where its gravity blends with that of our galaxy, where the distinction between here and there becomes less clear. This shared space belongs fully to neither galaxy. It is a transitional zone, quiet and vast, where gravity balances gently between two enormous systems. Over time, this balance will shift. Motion will continue. The galaxies will draw closer, guided by forces already at work. For now, this interaction remains subtle enough to be ignored. The night sky looks the same as it always has. Andromeda still appears as a faint blur. The Milky Way still surrounds us with stars. Nothing about their true width announces itself loudly, and that is the pattern repeated throughout the universe. The largest changes arrive quietly. The greatest scales reveal themselves only through patience. Andromeda's greater width does not demand attention. It does not alter the night sky in obvious ways. It simply exists, extending farther than expected, shaping space beyond what the eye can see. As this understanding settles, the galaxy begins to feel less distant and more present. Not because it is close in human terms, but because its influence already reaches us. The separation between galaxies becomes softer, more conceptual than absolute. The invisible structure. Beyond the stars that define Andromeda's visible form lies something far larger and far quieter. It does not glow. It does not reflect light. It cannot be photographed directly. Yet without it, the galaxy would not exist as we know it. This unseen presence forms the deepest foundation of Andromeda's true scale. This is the galaxy's dark matter halo. Dark matter does not behave like ordinary matter. It does not shine, burn, or scatter light. It passes through space almost silently, interacting primarily through gravity. Its presence is revealed not by what it emits, but by what it holds together. In Andromeda, dark matter outweighs all visible stars combined, forming a vast, invisible framework within which the luminous galaxy is suspended. From Earth, none of this can be seen. Images of Andromeda show swirling arms, glowing cores, and delicate dust lanes, but these features account for only a small fraction of the galaxy's total mass. Most of Andromeda exists beyond sight, extending far past the bright disk into regions where light grows thin and stars become scarce. This invisible structure defines the galaxy's true size more completely than light ever could. Astronomers first began to suspect the presence of dark matter by watching how stars move. In Andromeda, stars far from the center orbit at speeds that cannot be explained by visible matter alone. According to the laws of motion, they should drift away into intergalactic space. Instead, they remain bound, circling patiently in the dark. Something unseen must be holding them. This realization reshaped our understanding of galaxies. Andromeda was no longer just a collection of stars and gas. It was embedded within a massive, invisible halo, whose gravity extended far beyond the luminous regions. The galaxy's visible form became a surface expression of a much deeper structure. The dark matter halo does not have a sharp boundary. Like the galaxy itself, it fades gradually into the surrounding universe. Its density decreases with distance, but its influence stretches across hundreds of thousands of light years. In some estimates, Andromeda's dark halo reaches so far that its outer edges are difficult to distinguish from the broader gravitational field of the local group. This means that the galaxy's true size cannot be captured by images or even by the distribution of stars alone. It must be understood as a region of influence defined by gravity rather than light. Where stars and gas continue to respond to Andromeda's pull, the galaxy continues to exist. Within this halo, stars move in slow, graceful orbits. Gas drifts and settles. Small satellite galaxies are guided along curved paths, some eventually drawn inward, others flung outward. The halo acts as a quiet architect, shaping motion without revealing itself. From within Andromeda, the dark matter halo would not be felt directly. There would be no sensation, no visible sign. Its presence would be inferred only through the stability of the galaxy, through the way stars continue to orbit rather than scatter. The structure would feel natural, invisible, and complete. This invisibility makes dark matter easy to ignore. It does not demand attention, it does not announce its presence, and yet it accounts for most of what the galaxy is. The bright stars that define Andromeda's appearance are, in a sense, decorations on a much larger, unseen framework. This reframes the idea of scale once again. Andromeda is not large because it shines brightly. It is large because its gravitational influence extends far into space, shaping matter well beyond the limits of visibility. The galaxy's true dimensions are written in motion rather than light. As understanding deepened, Andromeda grew larger still, not in brightness, not in visibility, but in reach. The dark halo expanded the galaxy's presence into regions once thought empty. Space that seemed quiet and unused was revealed to be structured and dynamic, guided by forces that cannot be seen. This quiet expansion mirrors the universe itself. The most important structures are often the least visible. The deepest foundations remain hidden, supporting what we can see without drawing attention to themselves. Andromeda's dark matter halo does not compete with the stars for notice. It does not add spectacle. It adds stability. It gives the galaxy its coherence, its longevity, and its scale. As you rest with this idea, it becomes easier to let go of the need to see everything. The universe does not require visibility to exist. Its largest components operate silently, shaping reality without announcing themselves. Where Andromeda really ends. When we try to imagine the edge of Andromeda, the mind naturally looks for a boundary, a place where the galaxy gives way to empty space, a final point where its presence stops. This instinct comes from life on Earth, where endings are visible and surfaces are clear. But in space, and especially in a galaxy shaped by dark matter, endings do not behave this way. Andromeda does not end where its light fades. It does not end where its stars become difficult to see. And it does not end at any single distance that can be clearly marked. Instead, it thins gradually, its influence stretching outward in quiet, diminishing layers until it becomes indistinguishable from the surrounding universe. The dark matter halo is the key to this gradual ending. Unlike stars, which shine brightly in concentrated regions, dark matter forms a diffuse structure. Its density decreases slowly with distance from the galactic center, but it never drops to zero suddenly. There is no abrupt cutoff, no wall where gravity stops acting. The galaxy's presence weakens, but it does not disappear. This makes the question of where Andromeda ends more philosophical than practical. Astronomers can define regions where the galaxy's gravity dominates, where stars and gas are clearly bound to it. Beyond that, there are regions where influence overlaps, where it becomes unclear which galaxy a given particle belongs to, or whether it belongs to any single system at all. In these transitional zones, Andromeda's gravity blends with that of the Milky Way and other nearby galaxies. Space becomes shared rather than owned. The concept of a single galaxy giving way to another dissolves into a quiet overlap of forces. From Earth, this overlap is completely invisible. The night sky offers no hint that the galaxies are already interacting in subtle ways. The faint glow of Andromeda appears isolated and contained. Yet beneath that appearance, gravity is already weaving connections across millions of light years. This blending challenges the idea that galaxies are separate objects floating in isolation. In reality, they exist within a continuous cosmic web, connected by filaments of dark matter and shaped by mutual influence. Andromeda is not an island. It is a node in a larger structure, its boundaries softened by connection rather than defined by separation. The farther out one looks, the less meaningful the concept of belonging becomes. Stars at the very edge of Andromeda's halo move slowly, influenced by multiple gravitational sources. Over immense timescales, their paths may change, their allegiance shifting as forces balance and rebalance. The galaxy's outermost regions are dynamic, not fixed. This dynamism reinforces the idea that Andromeda's size is not static. It changes depending on context, on time, and on the perspective from which it is measured. In some eras, the galaxy's influence may extend farther. In others, interactions may reshape its outskirts, redistributing matter across shared space. From within the galaxy, none of this would feel dramatic. There would be no sense of approaching an edge, no moment of departure. Space would simply grow quieter, stars would become fewer. The sky would darken gradually. The transition from inside to outside would pass unnoticed. This quiet fading is difficult to imagine because it lacks drama. It does not match our expectations of endings. Yet it is precisely this lack of drama that defines cosmic scale. The universe rarely offers clear conclusions. It favors continuity over separation. Understanding where Andromeda ends, then, requires letting go of the need for precision. It requires accepting that some boundaries exist only for convenience, drawn to help us talk about structures that resist clean definition. The galaxy itself does not recognize these boundaries. It continues to influence space beyond them. This perspective reshapes how scale is felt. Andromeda becomes less like a finite object and more like a gradual presence. Its size is not a number to memorize, but a region to acknowledge. A space where gravity slowly loosens its hold, where structure fades into possibility. As this idea settles, the universe feels less segmented and more connected. Galaxies are no longer isolated entities. They are participants in a shared gravitational landscape, their influences overlapping, their futures intertwined. Overlapping halos. Although Andromeda appears distant and self-contained when viewed from Earth, its true presence extends far beyond its visible form. Long before any stars draw near, long before light from one galaxy begins to noticeably change the appearance of another, something quieter happens first. The outer reaches of galaxies begin to overlap. This overlap does not involve stars colliding or light suddenly intensifying. It happens in darkness, through gravity alone. Andromeda's dark matter halo stretches outward into space, just as the Milky Way's does. These invisible structures expand so far that they already share a region of influence, blending gently in the space between the two galaxies. From a human perspective, this is difficult to accept. We imagine distance as separation. Two objects, millions of light years apart, should feel isolated. But galaxies are not solid bodies. They are extended systems, defined not by edges, but by influence. When that influence reaches far enough, separation becomes a gradient rather than a gap. In the region where Andromeda's halo meets that of the Milky Way, gravity does not belong to one galaxy alone. It becomes shared. Matter in this space responds to both systems, pulled gently in competing directions. There is no sudden transition, no clear line marking where one galaxy ends and the other begins. This shared gravitational space has existed for millions of years. It formed quietly as the galaxies moved through the local group, their massive halos expanding and settling into the surrounding cosmic structure. Nothing about this interaction is visible to the naked eye. The night sky offers no hint that such a connection exists. Yet this overlap is real, and it is significant. It means that Andromeda and the Milky Way are already interacting, even though their bright stars remain far apart. Their future connection did not begin with motion alone. It began with presence, with influence reaching outward, slowly erasing the idea of complete separation. Within this overlapping region, motion unfolds at a glacial pace. Particles drift, guided by gravity so subtle that change is measured over millions of years. There is no sense of urgency. The universe does not rush these interactions. It allows them to develop naturally, shaped by balance rather than force. This challenges the way we imagine cosmic encounters. We tend to picture collisions as sudden and dramatic, but at galactic scales, interaction begins long before anything visible happens. It starts quietly, invisibly, as structures touch without contact. The overlapping halos also reveal how galaxies grow. Over time, smaller galaxies drifting nearby can become caught in this shared gravitational space. Some will be drawn inward, eventually merging with one of the larger systems. Others may be reshaped, their paths altered by the combined pull of both galaxies. These processes leave faint traces, streams of stars, subtle distortions in motion, and slight changes in distribution all record the history of interaction. Andromeda's halo, already rich with such traces, carries evidence of past mergers and quiet encounters. From Earth, these signs are nearly impossible to see without careful study. The galaxy's bright disk dominates attention, hiding the delicate patterns in its outskirts. Yet it is in these outskirts that the future of the galaxy is written. The idea that Andromeda is already touching us, not through stars or light, but through gravity, reshapes the meaning of distance. It suggests that separation in space does not imply isolation. Influence can bridge vast gaps, connecting structures long before they appear close. This connection is not threatening. It is not a prelude to catastrophe. It is simply the natural behavior of matter on large scales. Gravity extends, structures overlap, space becomes shared. As this idea settles, the universe feels less fragmented. Galaxies are no longer isolated islands, drifting alone in emptiness. They are participants in a slow, interconnected dance, guided by forces that act gently and persistently across immense distances. Andromeda is moving toward us. From Earth, the night sky appears steady and unchanging. Stars rise and set in familiar patterns. Constellations hold their shapes across generations. Even Andromeda, distant and ancient, seems fixed in place, quietly occupying the same region of sky year after year. Nothing about its appearance suggests motion. Nothing about its presence feels urgent. And yet, Andromeda is moving. It is not moving in a way the human senses can detect. There is no visible shift, no gradual swelling in size, no creeping change that can be followed with the eye. The motion is far too slow for that. It unfolds across millions of years, guided by gravity acting patiently across vast distances. Andromeda's approach toward the Milky Way is real, but it exists on a timescale that resists intuition. The idea that galaxies move toward one another can feel strange at first. Space is often imagined as static, a silent stage on which stars and galaxies are placed like decorations. But space is not a backdrop. It is an active environment shaped by gravity and motion. Galaxies drift through it, responding to forces that operate continuously, even when change is too slow to notice. Andromeda's movement toward us was not discovered by watching it change position in the sky. Instead, it was detected through light itself. Light carries more information than brightness and color. It also carries motion. When an object moves toward us, the light it emits is slightly compressed, shifting toward shorter wavelengths. This effect is subtle, almost imperceptible without precise instruments, but it is reliable. Measurements of Andromeda's light reveal this compression. The galaxy's glow is shifted in a way that indicates approach rather than retreat. While most distant galaxies are moving away from us as the universe expands, Andromeda is an exception. It is close enough and massive enough that gravity overcomes the general expansion of space between us. This approach is not fast. It is measured in kilometers per second, a speed that sounds impressive until it is placed in context. At galactic scales, even thousands of kilometers per second result in movement that takes billions of years to become visually meaningful. Distance on this scale absorbs speed easily, stretching motion into something that feels almost still. The space between the Milky Way and Andromeda is immense. Millions of light-years lie between their bright centers. Even as the galaxies move toward one another, that distance remains vast. The approach does not feel like closing in, it feels like patience itself. This patience is a defining feature of cosmic motion. The universe does not rush, gravity does not hurry. It acts steadily, continuously, without regard for human timescales. The movement of galaxies is less like a journey and more like a slow adjustment, a gradual rebalancing of space over time. As Andromeda drifts closer, nothing dramatic happens in the present. The stars of the Milky Way do not respond noticeably. The night sky remains calm. There is no warning, no sign, no visible change. The motion exists quietly in the background, like tectonic plates shifting beneath the surface of the Earth, imperceptible moment by moment, yet powerful over deep time. This slow approach challenges the way we imagine future events. We often picture change as something that arrives suddenly, with clear beginnings and endings. Galactic motion does not follow this pattern. There is no starting point where Andromeda suddenly begins moving toward us. It has always been moving, guided by gravity, since the earliest days of the universe. The galaxies formed relatively close together, emerging from the same region of the early universe. Their motion is not accidental. It is the result of shared history and mutual influence. Over billions of years, gravity has been shaping their paths, gradually drawing them closer. This shared history is written into the structure of space itself. The dark matter halos that surround both galaxies have already merged into a single, overlapping region. Long before stars approach one another, long before light from one galaxy begins to dominate the sky of the other, their invisible structures have already become connected. In this sense, Andromeda's movement toward us is not a future event. It is an ongoing process. The galaxy is not on its way in the way an object travels from one location to another. It is participating in a slow convergence that has been unfolding for millions of years. Understanding this requires letting go of urgency. There is no moment to prepare for, no countdown, no approaching impact. The timescale involved is so vast that entire civilizations could rise and fall without noticing even the smallest visible change. The Earth itself will be transformed many times over before Andromeda's presence becomes visually significant in our sky. This perspective softens the idea of motion. It removes threat and replaces it with continuity. The universe is not racing toward dramatic outcomes. It is adjusting, balancing, evolving at a pace that invites calm rather than concern. As Andromeda moves closer, its stars remain widely separated from those of the Milky Way. Galaxies are mostly empty space. The distances between individual stars are so great that even during a galactic encounter, direct collisions between stars are extraordinarily unlikely. The word collision, when applied to galaxies, is misleading. It suggests impact where there is instead transformation. This transformation, when it eventually unfolds, will take hundreds of millions of years. Stars will follow new paths. Orbits will change. Gas clouds may interact, giving rise to new regions of star formation. But these changes will be gradual, spread across deep time, unfolding quietly. From within the galaxies, the experience would feel subtle. The night sky would change slowly, almost imperceptibly, as stars shift position over many generations. There would be no sudden brightness, no violent disruption. The universe does not announce its changes loudly. For now, Andromeda's motion is a reminder rather than an event. It reminds us that even the largest structures in the universe are not fixed. They move, they evolve. They respond to forces that operate continuously, even when their effects are hidden. This motion also reframes the meaning of distance. The space between galaxies is not a static gap. It is an active region shaped by gravity, dark matter, and the slow flow of matter over time. As Andromeda moves toward us, the space between us changes as well, becoming increasingly shared. This shared space does not belong to either galaxy alone. It is shaped by both, influenced by their combined mass and motion. In this region, gravity becomes a conversation rather than a command, guiding matter along paths that reflect balance rather than dominance. The idea that Andromeda is approaching does not mean it is arriving. Arrival, like collision, is a human concept tied to immediacy. Galactic motion does not arrive. It unfolds. It stretches across time so vast that beginnings and endings lose their meaning. Andromeda's approach is best understood not as a future destination, but as a slow merging of influence. The galaxies are already affecting one another. Their motion is already entwined. The future is not something that suddenly appears. It is something that has been developing quietly all along. As this understanding settles, the idea of cosmic motion becomes less dramatic and more meditative. The universe is not racing forward. It is drifting, adjusting, finding balance over spans of time that invite reflection rather than fear. The night sky remains calm. Andromeda remains faint. Nothing demands attention. And yet, beneath that calm appearance, motion continues. Gravity works patiently. Distance slowly changes. The universe carries on its quiet transformation, unconcerned with whether it is noticed. Why stars rarely collide? The word collision carries weight. It suggests impact, force, and sudden change. On Earth, collisions are loud and immediate. Two objects meet, and something breaks, bends, or burns. Energy is released all at once. The event is clear, unmistakable, and brief. When this word is applied to galaxies, the mind instinctively reaches for the same imagery. But the universe does not behave this way. When astronomers say that Andromeda and the Milky Way will collide, they are using a word that fits human language more than cosmic reality. What is being described is not an impact in the familiar sense, but a long, gentle process of interpenetration and rearrangement, a slow transformation guided by gravity rather than force. Galaxies are not solid bodies. They are vast, loosely structured systems composed mostly of empty space. Even in the densest regions, the distance between stars is immense. On average, stars in a galaxy are separated by several light years. This means that if galaxies pass through one another, the chances of individual stars actually striking each other are extraordinarily small. To understand this, it helps to imagine scale differently. Picture two enormous clouds drifting toward one another. Each cloud contains countless tiny particles, but those particles are spread so thinly that the clouds can overlap almost completely without the particles ever touching. From a distance, it might look like a collision. From within, it would feel like a gradual change in density. This is what happens when galaxies meet. As Andromeda and the Milky Way draw closer, their stars will pass by one another silently, separated by distances so vast that direct contact is almost impossible. The galaxies will interweave rather than crash. Their shapes will distort slowly as gravity reshapes orbits, but there will be no explosive moment of impact. This reality often feels counterintuitive because galaxies appear dense in images. Spiral arms glow brightly. Star clusters seem packed together, but these images compress scale dramatically. They flatten depth and exaggerate proximity. In 3 dimensions, the space between stars is immense. If the Milky Way were reduced to the size of a city, individual stars would be separated by distances comparable to kilometers. Even during a galactic encounter, these distances remain largely unchanged. Stars follow new paths, but they do not collide. The primary agents of change during a galactic interaction are not stars, but gravity and gas. As the galaxies overlap, their gravitational fields combine, reshaping the motion of stars and clouds alike. Orbits that were once stable begin to shift. Stars are gently pulled into new trajectories, sometimes flung outward into extended arcs, sometimes drawn inward toward denser regions. This reshaping happens slowly. Over hundreds of millions of years, the galaxies stretch and bend, forming long tidal tails and faint streams of stars that trace their shared motion. These features are not signs of violence, but of gradual adjustment. Gravity works patiently, never hurrying, never forcing sudden change. Gas behaves differently from stars. While stars pass one another easily, clouds of gas can interact more directly. As Andromeda and the Milky Way begin to overlap, their gas clouds may compress and collide, triggering waves of new star formation. These events can create regions of intense light, but even this activity unfolds over long timescales. From within the galaxies, this process would feel subtle. The sky would change slowly as stars shift position over many generations. New stars might appear in certain regions, but there would be no sudden catastrophe. Life, if present, would not be extinguished by a moment of impact. The universe does not work that way. This gentle nature of galactic interaction reveals something important about scale. At cosmic sizes, energy is spread out. Motion is slow. Even dramatic events become drawn-out processes. The universe favors continuity over disruption. The idea of a collision, then, is misleading, not because it is wrong, but because it implies urgency where none exists. Andromeda's future interaction with the Milky Way is not an event to anticipate. It is a transformation that will unfold so gradually that it resists narrative structure altogether. This transformation has already begun in subtle ways. The overlapping halos discussed earlier are the first stage. Gravitational influence has already merged. The next stages will involve the gradual reshaping of stellar orbits and the slow blending of structures. Throughout this process, stars remain largely untouched by direct contact. Their journeys continue, guided by changing gravitational landscapes rather than physical encounters. Each star carries its own history, its own orbit, its own quiet path through space. This perspective shifts the emotional tone of the future. The idea of galaxies colliding often inspires anxiety or awe, but when understood properly, it becomes something calmer, something almost meditative. A reminder that even the largest changes in the universe happen gently. The universe does not shatter itself. It rearranges. This rearrangement is not chaotic. It follows patterns shaped by gravity and time. Structures emerge, dissolve, and reform in cycles that span billions of years. Galaxies grow by merging, not through destruction, but through integration. Andromeda itself bears the marks of past encounters. Its halo contains streams of stars left behind by smaller galaxies that were slowly absorbed. These streams are faint and delicate, evidence of interactions that unfolded quietly over immense spans of time. The Milky Way carries similar marks. Both galaxies are products of countless slow mergers, each one contributing stars, gas, and dark matter to the growing structure. The future interaction between them is simply another chapter in this long history. Seen this way, the idea of collision loses its drama. It becomes a continuation rather than a rupture. The universe has always behaved this way, building larger structures through gradual accumulation rather than sudden impact. As this understanding settles, the future feels less threatening and more expansive. The universe is not rushing toward an end. It is unfolding, layer by layer, transformation by transformation, without urgency. The future sky. When we imagine the future of the sky, we often picture sudden transformation, a dramatic moment when everything looks different at once. But the sky, like the universe itself, rarely changes in this way. Its transformations unfold slowly, almost imperceptibly, carried forward by time rather than force. As Andromeda continues its gradual approach, the first changes in the sky would not be obvious. For countless generations, the galaxy would remain much as it appears now, a faint, elongated glow, visible on clear nights. No single lifetime would witness a meaningful shift. The sky would feel steady, dependable, unchanged. This steadiness is deceptive. Over millions of years, Andromeda would grow subtly brighter and larger. The change would be so slow that it would escape notice unless recorded carefully across immense spans of time. What begins as a faint smudge would gradually stretch farther across the sky, its shape becoming more complex, its structure more apparent. The galaxy would no longer feel like a distant object. It would begin to assert itself as a presence. Even then, there would be no sudden moment of arrival. Andromeda would not rush into view. It would drift, guided by gravity, its light filling a slightly larger portion of the sky with each passing epoch. The change would be gentle, unfolding at a pace that invites reflection rather than alarm. As the galaxies draw closer, their outer regions would interweave more deeply. The halos, already overlapping, would begin to influence the visible stars more strongly. Stellar orbits would slowly adjust, responding to the combined gravitational field. The sky would reflect these changes not through chaos, but through gradual reorganization. From within the Milky Way, the night sky would begin to change shape rather than brightness. Patterns we recognize today would stretch and bend over long spans of time. Constellations would lose their familiar forms, not suddenly, but slowly, as stars follow new paths shaped by evolving gravitational forces. Andromeda itself would become a dominant feature of the sky. Its core would glow more brightly, its spiral arms becoming easier to trace. The galaxy would stretch across a large portion of the night, no longer a subtle presence, but a sweeping structure that commands attention. Even at this stage, the encounter would not feel violent. Stars would continue their journeys without disruption. Planets would maintain their orbits. The changes would be visible only in the sky, not felt on the ground. The universe does not announce its transformations with force. As time continues to pass, the two galaxies would begin to pass through one another. Their stars would intermix. their structures blending. The sky would become rich with overlapping star fields, layers of light crossing and recrossing. The distinction between Andromeda and the Milky Way would soften, replaced by a shared celestial environment. This blending would create a sky unlike anything we see today. Instead of a single band of the Milky Way stretching across the night, there would be multiple luminous arcs weaving together, filling the sky with light. Darkness would still exist between stars, but the sense of depth would deepen dramatically. Despite this richness, the experience would remain calm. There would be no sudden flares, no catastrophic bursts of energy visible from the surface of a planet. Star formation might increase in some regions, creating pockets of brightness, but even these would unfold gradually. Over hundreds of millions of years, the galaxies would lose their distinct spiral shapes. Gravity would pull stars into more randomized orbits, smoothing out structure and dissolving familiar patterns. The combined system would become more rounded, more diffuse, less defined by arms and disks. The sky would reflect this transformation. What was once structured and directional would become evenly distributed. Light would be spread more uniformly across the heavens. The sky would feel fuller, quieter, less focused on any single direction. Eventually, after immense spans of time, the two galaxies would settle into a new configuration. A single, larger galaxy would emerge from the interaction, containing the stars of both original systems. This galaxy would not carry the name Andromeda or Milky Way. It would be something new, shaped by the slow integration of both. From within this future galaxy, the idea of separate past systems would feel abstract. The sky would offer no clear hint that two distinct galaxies once existed. History would be written into motion and distribution, not into visible divisions. This future sky would be the result of patience rather than force. It would embody the universe's preference for gradual change. Nothing would be lost suddenly. Everything would be rearranged slowly. Thinking about this future can feel overwhelming if imagined all at once, but when allowed to unfold gently, it becomes calming. The universe does not hurry toward transformation. It allows time to do the work. The sky we know today is temporary, but it is not fragile. It will change, but not abruptly. It will evolve, but not violently. The future is not something that arrives suddenly. It grows out of the present, layer by layer. As this understanding settles, the future sky becomes less about spectacle and more about continuity. It reminds us that even on the largest scales, change is a process rather than an event. Standing inside the galaxy. It is difficult to imagine standing inside a galaxy, not because the idea is complex, but because it feels too large to hold in the mind. Galaxies are usually presented as images seen from the outside, flattened into elegant spirals and glowing disks. From that distance, they feel like objects, something separate, something that can be looked at all at once. But from within, a galaxy is not an object at all. It is an environment. If you were placed somewhere inside Andromeda, there would be no sense of arrival, no crossing of a boundary, no moment where the galaxy suddenly began. You would already be within it, surrounded on all sides by space filled with stars, gas, and darkness. The idea of inside would feel meaningless because there would be no outside to contrast it with. The sky would not resemble the images we associate with galaxies. There would be no visible spiral arms sweeping overhead, no glowing outline tracing the galaxy's shape. Those structures exist only when seen from afar. From within, structure dissolves into distribution. Stars would fill the sky unevenly, denser in some directions, sparser in others, but without clear edges or symmetry. The brightest stars would stand out, close enough to shine clearly. Most stars, however, would appear as faint points, scattered across the darkness. The sky would feel deep, layered, and expansive, but not crowded. Even within a galaxy containing hundreds of billions of stars, space between them is vast. Darkness would still dominate. This surprises many people. It is easy to imagine that being inside a galaxy would mean being surrounded by constant light. In reality, the distances between stars are so great that even within the dense regions of a galaxy, the sky remains mostly dark. Light is precious. It arrives from far away, traveling across empty space before reaching the eye. Within Andromeda, the night sky would feel familiar in this way. Stars would rise and set, patterns would emerge, though they would be different from those we know. The Milky Way would no longer stretch across the sky as a luminous band. Instead, it would appear as a distant galaxy, a faint glow among countless others. From this perspective, Earth would be invisible. The Sun would be just another star, lost among billions. There would be no marker to indicate where the Milky Way ends and Andromeda begins. The concept of galaxies as separate entities would feel abstract, a construct of distant observation rather than lived experience. Time would also feel different inside a galaxy. Motion unfolds slowly at this scale. Stars take hundreds of millions of years to complete a single orbit around the galactic center. Change happens gradually, almost imperceptibly. From one generation to the next, the sky would look much the same. This slow rhythm gives galaxies their sense of permanence. They feel ancient and stable because their changes are spread thinly across time. Even dramatic events, like bursts of star formation or the absorption of smaller galaxies, unfold over spans so long that they feel calm rather than violent. Standing inside Andromeda, you would not feel the galaxy moving. Its rotation would be too slow to sense. Its drift through space would be imperceptible. Gravity would hold everything in quiet balance, guiding motion without announcing itself. The galaxy's center would be somewhere, but not obvious. There would be no sign pointing toward it. Stars closer to the center would be more densely packed, their light more abundant, but this gradient would be subtle. The idea of a central region would be something learned, not something felt. In the outer regions, the sky would grow darker, stars would be fewer. The galaxy would thin gradually, blending into intergalactic space without ceremony. There would be no moment where the galaxy ended. Space would simply grow quieter. This quiet is an important part of understanding galactic scale. Galaxies are not loud places. They do not announce their size. They exist calmly, allowing time and gravity to do their work without urgency. From within Andromeda, the concept of size would lose its meaning. How large is the environment you are already inside? The galaxy would feel infinite, not because it truly is, but because there would be no clear reference for its limits. Distance would stretch outward without obvious markers. This is why galaxies are easier to understand from the outside than from within. External views provide contrast and shape. Internal experience provides immersion without boundaries. Both perspectives are true, but they reveal different aspects of reality. Inside Andromeda, the galaxy would not feel like a spiral or an oval. It would feel like space itself. Stars, gas, and darkness would blend into a continuous environment. The idea of structure would be something inferred rather than seen. This perspective helps explain why galactic scale feels so difficult to grasp from Earth. We are already inside a galaxy. We experience its environment without seeing its shape. The Milky Way surrounds us so completely that its vastness becomes invisible. Andromeda, viewed from afar, offers a rare opportunity to see a galaxy from the outside. But even then, we see only a surface representation, flattened and simplified. The true experience of a galaxy is always internal, always immersive, always boundaryless. As this idea settles, the galaxy begins to feel less like an object to be measured and more like a place to be imagined. not a destination, but an environment that exists whether or not it is observed. How large it feels from within. When you are inside something vast, size stops behaving the way you expect. It no longer announces itself through edges or comparisons. It becomes something ambient, something that surrounds rather than confronts. This is how Andromeda would feel from within. Not overwhelming, not dramatic, but quietly endless. Inside the galaxy, there would be no single moment where its scale became clear. There would be no point you could stand at and say, "This is how large it is." Distance would stretch outward in every direction without offering reference points. Stars would appear closer or farther, brighter or dimmer, but the galaxy itself would not present a frame. This lack of framing changes how scale is experienced. On Earth, size is understood through contrast. A mountain feels large because it rises above the landscape. An ocean feels vast because it extends beyond the horizon. Inside Andromeda, there would be no horizon in the familiar sense. Space would not curve away or end. It would simply continue. Generations could pass without any sense of movement across the galaxy as a whole. A star might drift slightly against the background over thousands of years, but the overall environment would feel stable. The galaxy's rotation is so slow that it would be invisible to lived experience. Motion would exist, but it would not feel like change. This stability gives galaxies their quiet character. They do not feel active or restless. They feel settled. Time moves differently when measured against structures that evolve over hundreds of millions of years. Days, years, even centuries become brief moments in a much longer rhythm. From within Andromeda, distance would not feel like something to cross. It would feel like something to exist within. Traveling between stars would remain impractical, not because of danger, but because of scale. The distances involved would be too large to hold emotionally. Space would feel open and patient, unconcerned with movement. Light would arrive slowly. Even nearby stars would be years away in terms of light travel time. Looking out into the galaxy would always mean looking into the past. The present would exist locally, while the broader environment would be layered across time. This layering would soften the idea of now. Inside a galaxy, there is no single present moment shared by all stars. Each region exists in its own, slightly delayed version of reality. The farther you look, the farther back in time you see. This makes the galaxy feel less like a synchronized system and more like a collection of overlapping histories. And yet, it would feel coherent. Gravity binds the system together, giving it a shared motion and structure despite these temporal separations. Stars follow predictable paths. Orbits remain stable. The galaxy persists as a recognizable environment across immense spans of time. This persistence is part of what makes galaxies feel so large from within. They are not fleeting. They do not come and go quickly. They endure. Their scale is felt not through size alone, but through duration. Andromeda feels vast because it lasts. From one generation to the next, the galaxy would appear almost unchanged. The same stars would fill the sky. The same patterns would repeat. Even events that astronomers label as dramatic, such as starbursts or mergers with small galaxies, would unfold slowly enough to feel gentle. The sky would change, but at a pace that allows adaptation. Nothing would happen suddenly enough to disrupt continuity. Life, if present, would grow accustomed to the environment, finding stability in the galaxy's slow rhythms. This slowness shapes perception. When change is rare, the environment feels permanent. When permanence dominates experience, scale expands emotionally. Andromeda would feel less like a place you occupy and more like a condition you exist within. Distance would also lose its urgency. Traveling across the galaxy would not feel like a journey toward a destination. It would feel like drifting within a vast medium. Movement would be local, incremental. without a clear sense of progress toward an edge. Even the galaxy's center would not feel central in any meaningful way. It would be brighter, denser, more active, but it would not announce itself as the core of everything. Without an external reference, center becomes a concept rather than a sensation. This is one of the quiet truths of scale. The largest structures do not feel large when you are inside them. They feel normal. They become the background against which everything else is measured. We experience this on Earth as well. The planet feels solid and still beneath our feet. Its motion through space is invisible to us. Its curvature is subtle. Its size becomes apparent only when viewed from afar. From within, Earth feels like a flat, stable environment. Andromeda would feel the same way. Its immensity would not be obvious. It would be inferred through time, through patience, through the absence of edges, rather than their presence. This internal perspective helps explain why galaxies can be so easily underestimated from a distance. When seen from outside, their scale is flattened into an image. When lived within, their scale dissolves into normality. In neither case does size announce itself clearly. Scale reveals itself slowly, indirectly, through implication rather than display. From within Andromeda, the idea of leaving the galaxy would feel abstract. There would be no clear direction to move toward an exit. Space would thin gradually, stars becoming fewer, but the transition would be subtle enough to go unnoticed without careful measurement. This makes the galaxy feel infinite, even though it is not. Infinity, in this sense, is not about endlessness, but about the absence of boundaries that matter to experience. Andromeda would feel infinite because it would never clearly end. This feeling of endlessness is calming rather than overwhelming. Without edges, there is no sense of confinement. Without abrupt change, there is no urgency. The galaxy provides a stable environment in which time can pass gently. As this understanding settles, the idea of galactic scale becomes less about numbers and more about presence. Andromeda is large not because it can be measured in light years, but because it offers space for time to unfold quietly. Compression of reality. Even after learning about galaxies, even after understanding their size, their motion, and their depth, something strange remains. Andromeda still feels small, not intellectually, but emotionally. The numbers may be clear, the explanations may be sound, yet the feeling does not change. The galaxy remains a faint blur in the sky, easy to overlook, easy to forget. This is not a failure of understanding. It is a feature of the human mind. The brain was not designed to feel cosmic scale. It was designed to compress reality into something manageable, to simplify the environment enough that decisions could be made quickly and reliably. This compression is not a flaw. It is what allows consciousness to function at all. Every moment, the senses are flooded with information: light, sound, motion, texture, and depth all arrive at once. The brain cannot process everything equally. Instead, it filters, prioritizes, and condenses. What is close matters more than what is far. What is changing matters more than what is stable. What threatens survival matters more than what does not. Cosmic scale does not meet these criteria. Galaxies do not change quickly. They do not threaten immediate survival. They do not require action. As a result, the brain assigns them low priority. They are relegated to background awareness, treated as scenery rather than presence. This is why Andromeda feels small, not because it is, but because it is safe to ignore. The same process applies to other vast things. The ocean feels manageable when seen from shore. The planet feels stable beneath our feet. Time itself feels linear and controllable, even though it stretches far beyond any single life. The mind compresses what it cannot act upon. This compression operates quietly. It does not announce itself. It simply shapes perception, turning vastness into abstraction. Andromeda becomes a concept rather than an experience, a fact rather than a presence. When something is abstract, it loses emotional weight. It can be acknowledged without being felt. This is why learning about cosmic distances often leaves people unchanged. The information does not integrate into lived experience. It remains separate, contained in thought rather than perception. The mind does this intentionally. Feeling the full weight of cosmic scale would be destabilizing. It would erode the sense of immediacy that allows daily life to function. Imagine feeling the age of the universe in every moment, or the distance to other galaxies in every glance at the sky. The mind would struggle to anchor itself to anything meaningful. So it compresses. Stars become points. Galaxies become smudges. Time becomes a sequence of moments. This compression creates a sense of control. The universe feels navigable because it has been reduced. Vastness is folded into manageable symbols. Andromeda fits comfortably into a small region of the sky because the mind allows it to. This process also explains why scale feels different when imagined slowly. When urgency is removed, when the mind is not required to act, the compression can loosen slightly. Space can be allowed to feel deeper. Time can stretch. Presence can expand. This is why long, slow contemplation changes perception. It does not add information. It removes pressure. Without the need to respond or decide, the mind can afford to let vastness exist without immediately reducing it. In this relaxed state, Andromeda can begin to feel larger, not because it suddenly appears brighter or closer, but because the mind stops shrinking it for convenience. Scale becomes something that can be sensed rather than dismissed. This sensing is subtle. It does not arrive as awe or shock. It arrives as quiet expansion, a gentle recognition that the sky contains more than it appears to. That distance has depth. That presence extends beyond attention. The feeling does not last long. Compression returns quickly when attention shifts back to immediate concerns. This is natural. The mind cannot remain open to vastness indefinitely without losing its ability to function in the present. Understanding this can be calming. There is no need to force cosmic scale into daily awareness. There is no requirement to feel the universe at all times. The mind's compression is protective. It allows us to live where we are. Andromeda does not need to feel large to be large. It does not need to be felt to exist. The smallness we feel when looking at the galaxy is not a statement about the universe. It is a statement about human perception, about what the mind chooses to emphasize and what it allows to fade. This understanding reframes the experience of looking at the night sky. Instead of feeling disconnected by the inability to grasp scale, there is a quiet acceptance. The universe is larger than feeling allows, and that is okay. Scale does not demand to be felt fully. It waits patiently, available when the mind is ready. Letting scale be felt. There is a difference between understanding something and allowing it to be felt. Understanding is active. It involves effort, comparison, and explanation. Feeling, on the other hand, is passive. It arrives only when there is no pressure to respond. Cosmic scale belongs to this second category. It cannot be forced into awareness. It must be invited gently, without demand. When the mind tries to grasp scale directly, it tends to shrink it instead. Numbers become symbols. Distances become abstract. The galaxy turns into a statistic rather than a presence. This is the mind protecting itself from overload, maintaining coherence by simplifying what it cannot act upon. Letting scale be felt means releasing the need to define it. This release does not come from ignoring information, but from changing how attention is applied. Instead of focusing on how large Andromeda is, attention shifts to how quietly it exists. Instead of trying to imagine all of its stars at once, attention rests on the idea that there are more stars than imagination can hold. This subtle shift transforms scale from something to be understood into something to be experienced indirectly. Feeling scale does not involve awe in the dramatic sense. It does not arrive as shock or amazement. It arrives as spaciousness, as a sense that the world is larger than immediate concern. That presence extends beyond urgency. That time moves more slowly than thought suggests. This is why cosmic contemplation often pairs naturally with calm. When urgency dissolves, scale has room to breathe. Looking at Andromeda without expectation allows this to happen, not asking anything of the galaxy, not requiring insight or meaning, simply allowing it to be there. In that quiet allowance, the mind stops compressing as tightly. The galaxy does not suddenly feel infinite, but it begins to feel less contained. This loosening is temporary, and that is enough. The mind is not meant to remain open to vastness indefinitely. It must return to the present, to tasks and relationships and immediate experience. But moments of openness leave an imprint. They soften the boundaries of perception, making space feel deeper even when attention moves elsewhere. This is why long-form, slow exploration of cosmic ideas can feel restful rather than overwhelming. It removes the demand for resolution. There is no need to conclude or decide. The universe is allowed to remain unfinished in the mind. Andromeda benefits from this approach. It does not demand interpretation. It does not insist on understanding. It simply exists, steady and patient, offering a scale that can be approached gently. In this gentleness, scale becomes less threatening. It does not diminish human experience. It does not erase meaning. Instead, it places experience within a broader context, one that feels expansive rather than small. This context can be comforting. When life feels narrow or urgent, the presence of something vast and slow can be grounding. It reminds the mind that not everything moves quickly. Not everything requires immediate response. Some things exist simply to exist. Andromeda is one of those things. Its light arrives quietly, unchanged by human attention. Its motion unfolds without regard for observation. Its size does not depend on being recognized. The galaxy does not need to be felt to matter. Letting scale be felt means accepting this independence. It means allowing the universe to be larger than our ability to contain it emotionally. It means releasing the need to personalize vastness. This release creates calm. The mind relaxes when it realizes it does not need to hold everything, that it can exist within something larger without understanding it fully. That meaning does not collapse when certainty dissolves. In this relaxed state, scale becomes a background presence rather than a challenge. The universe does not loom. It supports. It provides a sense of continuity that extends beyond immediate experience. This is not escapism. It is perspective. Perspective does not remove the present. It frames it. It allows moments to exist within a larger flow, making them feel less isolated. Andromeda, distant and quiet, becomes part of that framing. The galaxy does not intrude on daily life. It does not demand attention. It waits patiently, offering depth when the mind is ready. As this understanding settles, the feeling of smallness shifts. It no longer feels diminishing. It feels relational. Smallness exists alongside largeness, each giving the other meaning. We do not need to be large to exist within something vast. We do not need to understand everything to belong. The universe is not asking for comprehension. It is not asking for awe. It is not asking for reverence. It simply is. Andromeda's scale does not need to be felt all at once. It does not need to be carried. It can be touched lightly, allowed to pass through awareness without resistance. This is the quiet gift of cosmic scale when approached gently. It does not overwhelm, it reassures. It reminds us that urgency is not the only rhythm available, that slowness is natural. That continuity exists beyond immediate concern. As this chapter closes, the galaxy remains where it has always been. Its light continues to arrive. Its motion continues to unfold. Nothing has changed. Only the relationship to scale has softened. Andromeda as background. There comes a moment, often without noticing, when something vast stops demanding attention. It does not disappear. It does not move away. It simply settles into the background, becoming part of the quiet structure that supports awareness rather than occupying it. This is how Andromeda ultimately exists in relation to us. Not as a mystery to solve, not as a destination to reach, but as a presence that does not require engagement. In the night sky, Andromeda remains faint, even after everything that is known about it, even after its size, its motion, and its future have been explored. It does not grow brighter to the eye. It does not assert itself more strongly. Knowledge does not change its appearance. The galaxy remains what it has always been from Earth's surface, a quiet glow barely distinguishable from the darkness around it. This constancy is important. It means that the universe does not change its behavior in response to understanding. It does not react to being observed. It does not adjust itself to human curiosity. Andromeda continues on its path, rotating, drifting, evolving, regardless of whether it is noticed at all. This indifference is not cold, it is stabilizing. A universe that does not demand attention allows attention to rest. It allows the mind to stop reaching outward, to stop searching for significance in every detail. Some things exist without purpose, beyond existence itself. Andromeda is one of them. As the galaxy recedes into the background of awareness, it begins to function differently in the mind. It becomes a reference rather than a focus, a reminder of scale rather than a challenge to it. Its presence adds depth without asking for interpretation. This is how vastness becomes calming rather than overwhelming. When something does not insist on being understood, it can be allowed to exist quietly. The mind does not need to compress it aggressively. It does not need to defend itself against overload. Vastness can remain vast without threatening coherence. In this way, Andromeda becomes part of the mental landscape rather than an object of attention. Like the sound of distant waves or wind through trees, it is there without being central. It adds texture to awareness without becoming its subject. This shift happens naturally when curiosity softens into familiarity. The galaxy does not lose its mystery, it loses its urgency. Mystery can coexist with calm, urgency cannot. The night sky has always worked this way. Stars become background once they are familiar. The moon becomes ordinary despite its influence. Even the sun, essential and powerful, fades into routine presence. Andromeda joins this quiet category, known but not demanding. This does not diminish its scale, it reframes it. Scale does not need to be foregrounded to exist. It does not need to be felt intensely to be real. It can remain in the background, shaping perspective gently rather than forcefully. This backgrounding of Andromeda mirrors how the universe holds itself together. Most of what exists is quiet. Most of what matters does not announce itself. The structures that define reality operate steadily, without spectacle. Dark matter, gravity, time itself, none of these are loud. They do not flash or call attention. They simply persist, forming the framework within which everything else unfolds. Andromeda, vast and luminous in aggregate, participates in this quiet persistence. Allowing the galaxy to become background is not an act of dismissal, it is an act of trust. Trust that understanding does not require constant focus, that meaning does not evaporate when attention shifts elsewhere. This trust allows the mind to rest. When Andromeda becomes background, The pressure to interpret dissolves. There is no need to connect ideas or draw conclusions. The galaxy does not represent anything that must be resolved. It exists alongside thought rather than within it. This coexistence creates a sense of spaciousness. The mind feels less crowded. Thoughts can arise and pass without being overshadowed by vastness. The universe does not compete with experience. It supports it. In this state, the galaxy's true gift becomes apparent. Not information, not spectacle, but context. Andromeda provides a quiet reminder that existence extends beyond immediate concern, that time and space are broader than any single moment. This reminder does not need to be constant. It works best when it appears gently, then recedes. Like a horizon that remains present without demanding attention, it shapes orientation without becoming the focus of travel. As awareness drifts, the galaxy drifts with it, remaining present without insistence. There is no need to imagine its future or revisit its past. It can remain as it is, a steady glow arriving from deep time, unchanged by observation. This acceptance marks the beginning of release. Release does not mean forgetting. It means loosening the grip of analysis, allowing the universe to remain unresolved, letting questions stay open without discomfort. Andromeda does not need closure. It does not need an ending. It does not need to be placed neatly into understanding. It exists whether or not it is framed. As the galaxy settles into the background, the sense of scale it carries continues to work quietly. It expands perspective without effort. It softens urgency. It stretches time gently. The night sky becomes less about objects and more about space itself. Darkness becomes meaningful, not as emptiness, but as room. Stars punctuate that room without filling it. Andromeda rests among them, one presence among many, distinguished only by its quiet endurance. This endurance is not dramatic. It does not demand awe. It simply continues. No conclusion, only distance. There is no moment when the universe asks to be concluded. It does not pause and wait for understanding. It does not offer a final frame where everything aligns neatly. Instead, it continues, quietly and without emphasis, allowing attention to come and go as it pleases. Andromeda remains where it has always been. Its light continues to arrive from deep time, carrying no urgency, no message that must be received. The galaxy does not change its behavior because it has been observed, explained, or imagined. It does not respond to curiosity. It does not require acknowledgement. It simply exists, steady and patient, far beyond the rhythms of daily life. As awareness drifts, the need to hold on to ideas begins to soften. Concepts that once felt important lose their edges. Size, distance, motion, and time gradually release their grip. They do not disappear. They become less defined, less insistent. This softening is not loss. It is rest. The mind does not need to keep track of the universe in order for the universe to continue. It does not need to remember where Andromeda is, how large it is, or what it will become. Those things unfold on their own, independent of attention. When this independence is accepted, there is relief. The universe becomes something that supports awareness rather than challenging it. Vastness no longer presses inward. It expands outward, creating space rather than demand. Distance becomes something that allows breathing room, not something that must be crossed. Andromeda drifts farther into the background, not because it is moving away, but because attention is no longer holding it in focus. The galaxy does not fade. Awareness simply widens, allowing many things to exist at once without competition. Stars remain in the sky. Darkness remains between them. Time continues its slow passage. Nothing is required to happen next. This is how the universe feels when it is no longer being measured. Without measurement, scale loses its sharpness. It becomes an atmosphere rather than a quantity. The galaxy is no longer millions of light years away. It is simply distant, quietly present, unconcerned with proximity. The future does not need to be imagined. The past does not need to be revisited. The universe does not move toward resolution. It moves through continuity. This continuity is soothing. It reminds the mind that not everything must arrive somewhere. Some things persist without destination. Andromeda does not travel toward meaning. It travels because gravity guides it. It exists because existence allows it. There is nothing to anticipate. Even the idea of change becomes gentle. The galaxy will evolve. The sky will shift. Structures will transform. But all of this happens without haste. The universe does not rush toward its own future. It unfolds at a pace that allows rest. As awareness continues to drift, thoughts slow, images soften, the need to understand gives way to the comfort of not needing to. The galaxy remains unchanged by this release. Andromeda does not notice when attention turns away. It does not become smaller or larger. It does not respond. It continues to rotate, to drift, to exist within the vastness that holds it. This lack of response is not emptiness. It is stability. A universe that does not require attention is a universe that allows rest. It does not demand participation. It does not require meaning to function. Andromeda is part of that stability, a distant structure, vast beyond feeling, yet calm enough to fade gently into the background of awareness. There is no final image to hold on to, no last idea to remember, no conclusion to reach, only distance, stretching quietly outward. Distance not as separation, but as space. Space not as emptiness, but as room. The galaxy remains. The sky remains. Awareness drifts. And in that drifting, the universe continues exactly as it always has. Unconcerned, unhurried, at rest.